In today's video I will explain how to fit a box collider into the exact shape of an orthographic camera. There you go, that's the script. As you can see, it's a really short script, so if you're in a hurry you can pause the video right here, make a script called calculate camera box, then just type all this out and attach it to the camera. All you need is to add a box collider 2D to the camera and make it orthographic, and just make sure these numbers are 0011. And that's it. As you can see, the box collider now fits perfectly into the camera. This works with every aspect ratio. It even works if I select free aspect and mess around with Unity's layout. Now admittedly, you should probably put the entire code in the start function because you don't really need to make this calculation at every frame. You probably just need to calculate it once at the beginning of the stage, but that is completely up to you. I put it inside update just to show you how the box collider changes in real time. Now, if you have a little bit more time to spare, I'd like to explain what the benefits are of having such a box collider and how this code actually works. But before we continue, I know that some of you may be worried about using an orthographic camera. See, a perspective camera has a natural parallax effect that a lot of people like to use. But please don't worry, because in the next video I will explain how to set up parallax layers with an orthographic camera. Alright, first I'm going to list some of the benefits of this box collider and then I'll explain how the code works. This perfectly fitting box collider can now be used as a base for anything related to your camera. You can enable objects when they enter the camera. You can disable objects when they exit the camera. You can make the camera follow the player but also not go outside the boundaries of the world. You can set up UI and HUDs much better this way. For example, player's health, you can put it in any corner of the screen much more easily. This also helps with ultra widescreen support. For example, my video game Balkadia supports 21:9, 32:9 and dual monitor. In my opinion, I think it's high time 2D indie games stopped limiting themselves to just 16:9. I'm sure there's more benefits to this, I just can't think of any more right now, so let's just see how this code works. First, we declare some private variables. This is for the camera component, this is for the box collider. And these floats are going to be used for the calculation. Then we type this in the start function. If you're not familiar with programming, all this does is make sure these two variables correspond to these two components in the camera, which will then allow us to make changes to those components. So why is size y equal to orthographic size times 2? Well, if we select an aspect ratio of 1:1, we get a perfectly square camera. If we then make the camera size equal to 1 and the box collider size equal to 1, we will notice that the camera is 2 times bigger than the collider. Same thing happens if we add a cube or a quad. Now, this might be because Unity draws the camera from the center, so it goes 1 up, 1 down, 1 left and 1 right. But most likely Unity draws everything else from one edge, so it would just go 1 up and 1 right. I'm not exactly sure if that's what's causing it, but yeah, that's the reason for this. But why is size x equal to size y times ratio and not the other way around? Well, that's pretty simple. It's because no matter what aspect ratio you choose, the camera height always remains the same. It's the camera width that changes. So that's why. But what is ratio? Well, it's just a simple calculation that compares the camera width to the camera height. You simply divide screen width by screen height to get this ratio. Just make sure to convert the numbers to floats when you're dividing, and in the case of 16:9, the ratio is roughly equal to 1.78, meaning that the camera is roughly 1.78 times wider compared to its own height. And then, after all the calculations are done, we simply use vector 2 of size x and size y to scale the collider. This concludes today's tutorial. Tomorrow at 7 AM Eastern Time, I will upload a new tutorial about how to set up parallax layers with an orthographic camera. So if you don't want to miss that video, subscribe to the channel, hit the bell and select all. And if you found this video helpful and you want to show some support, please check out my video game Balkadia. It's still in development, but it now has a playable demo on Steam, so if you like it, you can wishlist my video game.